What are the Y2 Kelvin parallels for quantum disruption? Imagine waking up on January 1st, 2000, and fearing that computers would crash, banks would fail, and chaos would reign. The Y2 Kelvin problem was a real concern, and now we face a new challenge: quantum disruption. Let's look at how these two situations are similar and what we can learn from them. Both the Y2 Kelvin issue and quantum disruption present foreseeable threats that could impact the entire globe. The Y2 Kelvin problem arose from older computer systems that could not handle the date change at the millennium. Similarly, quantum disruption, often called Y2K, comes from quantum computers that could break current security measures. This means everything from online banking to healthcare could be at risk if we do not prepare. Next, both situations requiring large-scale efforts to update our systems. For Y2 Kelvin, organizations spent years fixing code and hardware to ensure everything would work correctly on January 1st, 2000. With quantum disruption, we need to transition to new security methods known as post-quantum cryptography. Unlike Y2 Kelvin, we do not have a set deadline for this transition, making it harder to plan. Investment is another key similarity. The Y2 Kelvin fix cost hundreds of billions of dollars, but early action helped avoid disaster. Now, organizations must invest in quantum-safe security measures to prevent breaches when quantum computers become powerful enough to break current encryption. Communication is vital in both cases. Explaining the risks and necessary changes to non-technical stakeholders, such as executives and policymakers, is essential for securing the necessary budgets and support. However, there are differences too. The Y2 Kelvin problem had a clear deadline and could be tested by simulating date changes. In contrast, quantum disruption's timeline is uncertain and cannot be fully tested until we have powerful quantum computers. Also, Y2 Kelvin fixes were mostly software updates, while quantum disruption requires fundamental changes to security methods, which could affect system performance. From a societal perspective, quantum disruption is more complex. It involves external threats from malicious actors who could exploit quantum capabilities, not just internal system bugs. Preparing for quantum disruption means upgrading technology and building awareness across industries and governments. Organizations should start by taking stock of their cryptographic assets, assessing vulnerabilities, and planning the shift to quantum-resistant algorithms. This preparation aligns with the need to manage the impact of quantum disruption on security, privacy, and trust in digital systems. As we look ahead, it is clear that while the Y2 Kelvin problem was a known bug with a clear deadline, quantum disruption is a gradual challenge. It requires ongoing vigilance, innovation, and collaboration to protect our digital future.